All right, Logic fans, welcome to our third video on 5.1. In this video, 5.1c, we're going to formally define an interpretation now that we've worked through some examples and you understand the intuitive idea. So, you always have an interpretation of a sentence, okay? And by a sentence, I mean the things we formally defined in Chapter 4, so, the form. So, for example, you have an interpretation of a sentence like this. Notice, this is a conjunction. Right? That's the main connective. Its left conjunct is a universally quantified sentence, and its right conjunct is a disjunction. Okay? So, you always have an interpretation of a sentence, right? One single sentence considered alone. Okay? Now, in order to be an interpretation, you have to specify an unambiguous domain of discourse over which the quantifiers of the sentence range. So, if we're trying to provide an interpretation of this sentence here, okay, first thing we have to do is specify an unambiguous domain of discourse. What I mean by unambiguous is it has to be precisely clear so that there's no question over what's in the domain and what's not, okay? So, first thing we have to do is we have to say, okay, what's our domain going to be? Well, maybe it's just going to have three things. It's going to have Mickey, Minnie, and it's going to have Pluto in it and nothing else, okay? So, the number 2 is not in there. The Christmas trees are not in there. Just Mickey, Minnie, and Pluto, okay? And it's unambiguous what's in there and what's not. And notice this is what the quantifiers of the sentence. So in this case, in this sentence, we have this quantifier. And that quantifier, when it says everything, is talking about these three things. Okay, it ranges over these things in the domain and only those things. Okay, the second thing that an interpretation has to do is it has to specify an unambiguous association between the individual constants of the sentence, okay, and the domain of discourse. So, we can do it this way. So the individual constants, right? So what individual constants do we have? Well, we've got the individual constant C and we've got the individual constant D. If there are no individual constants in the sentence, you don't have to worry about this parameter, but we've got C, and so maybe we're going to make C stand for, we're going to say that C stands for, it's got to stand for some member of the domain, okay? And C and D could stand for this, so they could both denote Mickey, okay? But we'll make C stand for Minnie, and we'll make D stand for, Pluto, okay? So there's got to be an unambiguous association between these guys and which members of the domain they pick out. They can potentially pick out the same one. Okay, that's what that means. And notice this is exactly what we did in the previous examples in the previous two videos. The final thing we have to do is we have to specify an unambiguous association between the property constants of the sentence and the property they stand for or they signify. So property constants. Okay, so in this particular case, in this sentence, we've got three property constants. We've got f of x, we've got g of x, let's say, and we've got j of x, let's say. Okay, so we got to say what property this denotes. We got to say what property this, signifies, let's say, or represents. Okay, and we got to do the same thing for this one. You have to do it for all of them that are in there. Also, the property constants, that includes in this case, okay, relational constants. So if you're studying relations and you've got, a sentence that has something like this in it, then you've got to say that, that stands for, X loves Y or something like that. So this would be read A loves B, okay? You would have, so the property constants include specifying those as well. All right, so in this particular case, let's say what f of x stands for. Well, f of x is going to stand for, is mean, okay? And g of x is going to stand for, let's say, is pleasant, okay? And j of x is going to stand for, is a dog, okay? All right, so let's just sort of do that. So on the, notice this interpretation is just what we did in the previous two videos. It's just that I've sort of formally laid out what an interpretation of a sentence is, and it does all these things, right? So on this interpretation, this sentence says everything in the domain, Mickey, Minnie, and Pluto, is such that they're not mean, okay? And C, which is Minnie, is pleasant, and either Minnie is pleasant, or it's not the case that Pluto is a dog. Okay, and that's what it means. Now notice this conjunct is true. Okay, everything in our domain is such that it's not mean. Moreover, this conjunct, right, turns out to be true as well because Minnie is pleasant and it's a disjunction. Okay, so this disjunct is true, making the whole disjunction is true. So this whole sentence on this interpretation turns out to be true. Okay, in other words, an interpretation has done everything that it needs to do to render the form in question, the sentence in question, the thing from chapter 4, true or false. It's provided it with a meaning, and that's the whole point of an interpretation. Okay, now coming up with interpretations on the fly is a very difficult thing to do. Right now, you know, people like me and your logic instructor have a lot of experience doing it, so we can kind of come up with domains and play with these things in different ways, and you'll acquire some experience with it too. But keep in mind that when we get to the next section, 5.2, we will offer you a streamlined way of presenting and coming up with interpretations on the fly that you'll find very, very nice and easy to use and implement. Okay, but for now, it's really important that you see all this and you have this intuitive idea of what an interpretation is. Okay, an interpretation, just these things, and thereby confers a sentence from chapter 4 with a meaning, i.e., renders it true or false. Okay. In the meantime, common domains you can use are, the students in your logic class, the Harry Potter characters, anything that you have like a lot of familiarity with. I recommend using the positive integers, or maybe the first 10 or the first 3 positive integers, something like that. Okay. You can, but the sky's the limit. You could use the colors, you could use the days of the week, whatever you might like. But the positive integers or some subset of them, okay, the students in your classroom, these are all good. And so let's, noting that, jump into some examples to finish this video off. All right, then, let's go ahead and start with the categorical A sentence as an example, okay? And can you provide me with an interpretation? Here's your definition, okay? Which makes this sentence true? And can you provide me with an interpretation of the categorical A sentence, which makes that sentence false? Pause now. Okay, so hopefully you've had a chance, and I'm going to just sort of present it this way. Okay, so the interpretation that makes it true is given this way, and an interpretation that in green, and an interpretation that makes it false I'll do in red. But yeah, so in this case I chose a domain of all the animals, all of them. Okay, there are no individual constants in this particular sentence, so we don't have to worry about that. Okay, but we do have the 2 property constants. Okay, so f of x, stands for the property of being a mammal, or signifies that property. Okay, and g of x signifies the property of being a vertebrate. So on that interpretation, the meaning of the sentence, and it's true, is that for any animal, pick anything you like out of our domain of discourse. Psst, the animals. Any old thing you pick out of there, anything you pick out of there, it's guaranteed to satisfy the following description. If it's a mammal, then it's a vertebrate. Okay, so that's the meaning of the sentence. All mammals are vertebrates among the animals. Okay, that's the idea behind the sentence. Okay, and notice, to make the categorical A sentence false, we can do roughly the same thing, but I've switched g of x from is a vertebrate to is a bird, and that provides us with the sentence: pick anything you like out of our domain. It will satisfy the following description. If it's a mammal, then it's a bird, which of course is false, right? No mammal is a bird, right? So that would be an interpretation of the categorical A sentence that makes it false. Okay, let's go ahead and try the categorical E sentence, which looks like this. Pause now and provide me with an interpretation that makes it true and an interpretation that makes it false. We'll come back and do it together. Okay, so to make the categorical E sentence true, right, we can just use the is a bird, right? We can use the same one, right? Because now we're saying pick any old thing you like out of the domain, it will satisfy the following description. If it's this, namely if it's a mammal, then it's not the case that it's a bird, which is true, right? So this works just fine for making the categorical E sentence true. For making the categorical E sentence false, we can simply revert back to making this vertebrate, okay, is not a vertebrate, okay? So let's go through it, but pick any old thing you like out of our domain. That thing you picked out, whatever it was, is guaranteed to satisfy the following description, right? If it's a mammal, then it's not the case that it's a vertebrate, which is false as desired, so this should be in red, okay, like that. All right, let's keep clipping along here. So let's go ahead and try now the categorical I sentence, which looks like this. Provide me with an interpretation that makes it true and an interpretation which makes it false. Pause now. Okay, so for the categorical I sentence, making it true in green here, okay, we've got at least one thing is both F and G, okay, some one thing is both F and G. So I made our domain the candies, okay, so you know, you've got Sour Patch Kids in there, Red Vines, M&Ms, and so on, and you know, we don't have any individual constants, don't have to worry about that, and I just made this sweet and this sour, okay. And so for some candy, for some one candy, it is both sweet and sour. Okay, so somewhere in Santa's bag there, somewhere in our domain, might not be the first thing you pick out, all right? There might be infinitely many things in there, whatever, but at least one thing in there satisfies the following description. It is both sweet and sour. Okay, and that's clearly true, right? Okay, so how can we make the categorical I sentence false? So here's what I came up with for making the categorical I sentence false. And if you're having trouble coming up with these on your own, notice you're getting a lot of exposure to different ones here, and there's more in the textbook and you know, more in the exercises and problems, and the more exposure you get, the better you're going to get at it. But again, starting in section 5.2, we will have a way of presenting interpretations that really streamlines this process and makes it much more efficient. You'll really dig it, so stay tuned for that. But it really is important for you to have these ideas in your back pocket. So to make the categorical I sentence false, I took a domain of polygons, right? So I'm picturing like a two-dimensional Euclidean polygons, okay? And then you have has exactly 3 sides, has exactly 4 sides. So this would say that for some polygon, for at least one polygon, it has exactly 3 sides and it has exactly 4 sides, which of course is false. Okay, categorical O statement, please, which looks like this, an interpretation that makes it true and an interpretation that makes it false. Pause now. So here again I have animals and then is a mammal and flies. So at least one thing in your domain of discourse, at least one thing in that bag, it is a mammal and it does not fly. Right? So you and me, for example, so that would be true. To make it false, here I chose musicians, and then, you know, being a virtuoso pianist for F and for G is talented, so then you would be left with at least one thing in the bag is both a virtuoso pianist and it's not talented, which is clearly a false statement, okay? So that makes the categorical O statement false. All right, logic fans, that's going to be it for this video. Okay, there's plenty of practice problems in the text. In the next section, we will dive into a streamlined way of presenting interpretations known as tableau techniques, which I think you'll really dig for their facility and ease of use. But do those practice problems, and we'll catch you on the next one.